Hi guys, Shouvik here. Welcome back to my YouTube channel. So today we will solve another beautiful questions from uh, Leetcode 3306 it is. So yeah, today's questions is we have to count of substrings containing every vowels and k consonants. Yeah, so let's understand the question first. So what is given to us? You are given a string of word and a non-negative integers k. So k can be 0 to any positive integers 0, 1, 2, 3, something like this. Return the total number of substrings of word. So and another word is given to us. Now on that word, return the total number of substrings of word that contain every vowel. So what are all the vowel in alphabet? A, E, I, O, U. So they are all vowels, and the word is given to us that is of lowercase English characters only. So that is mentioned here. So it contains lowercase English letters. Now on this word we have to found all the substrings which contains every vowel. A, E, I, O, U are our vowel at least once, and exactly k consonants. So consonants are without vowel, other than vowel from A to Z, without other than vowel, other characters are known as consonants. So the word that is given to us, we have to found a substring. A valid substring can be, we have to return the total number of substrings. We don't have to arbitrarily return any substrings. We have to return the count of total number of substrings in the word. So substrings is a contiguous part of strings of the word. So for example, like a, e, I, O, that is a substring, or a, E, I, O, Q, that is a substring, or e to from e to this, that is another substring, like this. So now we have to return the total number of substrings of what. So now which has exactly k consonant and holding all the vowels at least once. So vowels count can be more than once, but all type of vowels A, E, I, O, U should be present. So yeah, now let's try to understand the test cases. So on this word, you can see we need one consonant on a substring and all the vowels A, E, I, O, U at least once. But here you can see U is altogether missing. So there is no substrings is altogether possible we can build. Sorry. Here you can see that A, E, I, O, U, K is 0. So on the valid substring, all are alphabets only. We don't need any consonant. So there you can see, if you take the entire substring A, E, I, O, U, then that is a valid substring, because all vowels are present there, but no consonant is present. So that is a valid substring. Now on this you can see that k equals to 1, our output is 3. So from 0 to 5, 0 to 5, this, from 0 I to this Q, that is one answer. From 6 to 11, from 6 to 11, 11 is this, there is another answer. And from I to Q, that is from this I, that is from 7 index to end, there is another valid answer. So here you can see how it is valid. So on this, Q is a consonant, only one consonant, and all others A, E, I, O, U, all are vowels. Similarly, here you can see Q is only consonant. Here you can see Q is only consonant, and all others are vowels. Yeah, I think the question is pretty straightforward. Now, what make these questions challenging? It is medium, or I have to say, like, if you don't know the exact concept is going to be implement here, then that is more than medium. It is on interview perspective. If you don't know the data structure or the algo you have to build prior of appearing for that interview, then that is a super hard question for you for sure. Yeah, the what makes this actually difficult, the constant basically. So the brute, we can think that we will run a nested loop. We will start from I to I from like 0 to n, and j is also going to be start from uh, I to n. And when we will check, like, let me show you how it is. So this is something like, if I can show you, yeah, so this is something like, let's suppose, yeah, so if you have A, B, what happens if we have A, B, C, D, E, A, something like this. Any arbitrary string is given to us. Now we will start a I loop from here till n, and we will start a j loop. We will start a j loop from we'll start a j loop. J loop is going to be from I to n, and so that is a for loop and that is a for loop. And within this for loop we will check that from I to the current substring. What is the current substring? The substring from I till j is valid or not. Is valid. Is valid. Is valid is a function which will take this substring and giving you a response. So if is valid return you a true, it is a valid substring, then you can do a answer plus plus. And otherwise we don't have to do. And at the end just return our answer. Yeah, that's it. And now how you are going to check is valid functions with the substring, that is super simple. Like you can check it on, what I can say, you can check it on big of 1 only. Like if I can create some paste, if you can start with a consonant count variable. So consonant count variable initially is 0, and inside the for loop, inside the for of I loop, you can start a consonant count and you can start a distinct vowel count. You can consider it as a set. You can consider it as a set, right? So now when a particular character at word of j, if that character is a vowel, I'm pretty sure you should be able to check if it is a vowel. Just create a set of AEIOU and check if that particular character is belong to that. And if it is vowel, then add this, the vowel set dot add that particular character. And if it is a consonant, if vowel, else consonant count plus plus. Now is valid function is on is valid function, you just going to check, you will do these things on is valid function altogether. So that is inside is valid function, if consonant count equals to k, that is one conditions, and your length of vowel set equals to what? Vowel set equals to 5. If it is so, then return true, that is a valid. Otherwise return false. Yeah, that should be your pseudocode. But again, on this, the time complexity is, here we are basically, where it is, yeah, here it is. So here basically we are running 2 for loops. So one is from I to n and another one is from j equals to I to n, and j loop is running from I to n, and I is running from 0 to n, that is of starting to n, and j is running from I to n. So yeah, that is very standard quadratic time complexity, that is a big of n square type of complexity. And as per the question, it is mentioned that the n can grow at max of 2 into 10 to the power 5. So that is 2 into 10 to the power 5 into 2 into 2 into 10 to the power 5 raised to the power 2. So that means you are going to get 4 into 10 to the power 10, which is giving you a for simple straightforward TLE, correct? So now we have to think something better. Now if you I'm like very frankly stating, if you are if you want to solve such kind of question, then you should be first understand the concept of sliding window. So I am not going to explain the sliding window concept on this video, but if you want to make me to a dedicated video on sliding window, then I will be happy to do so. But yeah, on that questions, the most, so that is the brute I mentioned you, but the optimal solution is based on not a fixed size sliding window, that is a variable size sliding window. So please learn this topic prior of solving this question, variable size sliding window. Just Google it or search on your YouTube, you will find some like fruitful videos or some blogs. First learn this and then only try to solve this question, then you are going to solve it. Yeah, but if you want, I will make a video. I will please make a comments. Then only I can do the prioritizations of these things. Sure. Now let's try to understand how sliding. I am going to code only because I am not going to explain the sliding window in depth on this video. Otherwise, it is going to be a 1 hour long video or maybe more than that also. Yeah. Let's jump on the code altogether. So on code guidance, I will give you a hint how I am doing a sliding window. So for sliding window, the basic template you will going to be start with a left pointer and right pointer. Then for fixed size sliding window, though it is very simple. I think on the last video I have explained entire concept of fixed size sliding window. But for variable size, there is some like intelligent gameplay you have to follow to make your window on the there is size is not a matter, but your validity of the window is a factor. So make your window in a valid window. So basically here size is not a matter. So you have to just be very careful when your window is going to be going to be an invalid window. On that times you have to shrink your window. But on fixed size sliding window, you first set your pointer left and right with the size required, and then you can eventually shift it one place, something like this. But for variable size sliding window, it can be shrink to very small to very large, very shrink to very large. So shrinking is happen when there is an invalidity going to be happen on the sliding window, and expansion is going to be happen when basically expansion is all the time. So when that is under our validity, we are going to expand our window, and when it is an invalid window, we are shrinking the window. So that can be vary on question to question perspectives. Some questions we are expanding on the window when it is invalid, and some questions we are shrinking our window when it is invalid. That actually very question specific. But there is no as such rules on which questions you have to put to it. That actually you should be come from your brain itself by seeing the question altogether. But first learn the variable size sliding window general template, general idea how it is working. But yeah, let me just iterate you guys with the guidance altogether. Then also you are going to get a taste of variable sliding window for sure, because I have written my own template and will be explaining that only to you. Sure. So now we have first I have initialized my n with a len of the word, and I have initialized with a vowel set, which is basically holding all the vowels. And now just I have iterated over all the vowels a e i o u and add it to a set. So why I have added this to a set? Because set is going to be any element on any element presence. If we want to check any element's presence in a big of one time complexity, then set data structure is going to be able to calculate that. So we need to do a set. I think you guys are already aware of this thing, so I am not going to be very deep how set is doing so. So I am not going to explain that. But yeah, like set data structure is able to vend out the information in big of one time complexity if a particular element is altogether present or not. Then I have created a vowel map. Now on vowel map, I have created a DQ. So why DQ? I will explain. Now what this vowel map basically storing? A vowel map basically for A which index A has occurred. Like if we have a window, because on that particular question it is mentioned that a valid window can have a particular vowel multiple times. So the basic condition is every vowel should have at least once. A E I O U should have at least once, but their occurrence can be more than once also. That can be possible. So let's suppose A has occurred multiple times, 5 times. So which of the index A has occurred, this is going to be stored in a DQ. DQ you guys know, I'm guessing you guys know, DQ is basically a list altogether, but it has going to provide you an extra feature. Like you can, for list, you can pop an element from very rare in big of one time complexity, but on basically a queue, DQ, double-ended queue, you can add and delete an elements from the very front of the queue also in big of one. So that is like open on both the end. You can push and pop on both the end on big of one time complexity. So that is an inbuilt data structure of Python DQ. Every language should have its own double-ended queue, I have to say. And I have taken a consonant queue. So consonant DQ is also going to be stored the same information, which particular index the consonant has occurred. Now I have initialized my vowel count, my answer, and my left and right pointer. So that is a general template. Like you have your left and right pointer starting at 0,0. Now see how I am calculating my answer. That is actually very interesting. So just follow how I have like named the variables. It is very proper, very clear. Just by reading the names of the variables, you guys are going to get what actually the variable is storing, what actually the operations are performing. The similar way, please try to write the code on the similar way on the interview. That is going to be superly impressed your interviewer, because that is actually industry standard code. And also on the Leetcode template, we are following the functional programming like class and object oriented programming only. So yeah, please make your variables and functions. If you're writing any functions, please make a proper namings to that and name your variables, not A, B, C, D, I, J, K, L. Please name them accordingly. Cool. So we have initialized our left and right pointer from 0, 0, and now we are iterating on that. So what we are doing very standard. So that is my own template. Just if you guys want to use that, so please make a copy of that. That is going to be fit on most of the variable size sliding window questions. Yeah, let me explain to you guys. So my word, so what I am doing, I am iterating I am going to my right pointer to be on the expansion, and on right pointer expansion, what is the characters I got it on the right, I stored at character right. Now if character right in vowel, so that is going to be, I am checking on the set, so that is a big of one, so that's the reasons I taken a set here. Now if it is a vowel, then what I am doing, I am appending which particular index it's occurred. So right is basically pointing the index. So I have appended the character right at that particular index, and my vowel count. So far how many vowels I have encountered, I am storing. So if my len of vowel map of this particular characters we just pushed, if that is equals to 1, so that means these particular characters, what all the index that particular vowels has occurred. So what is the length of the vowel map of that, what vowel map for that particular characters, what are the indexes this particular vowels has occurred. This is going to be vended out by this list, and I am checking its length. So that means if its length equals to 1, so that means it is the first times it has occurred. So that means we got a very unique vowels for our first go. So that means our vowel count is going to be increased. So what vowel count is going to be stored? Vowel count is stored how many unique vowels till now we have encountered, because we need every vowels to be at least once. So there can be case, right? A has occurred 3 times and E has occurred 2 times, but I O U is altogether not occurred on that particular window. Then that particular window or the substring is not valid. So how we will validate that it is valid or not? By this vowel count. So this vowel count is going to be status if our unique vowel count is 5 or not. So to make a particular window valid, we need vowel count is 5 and consonant count is equals to k. Then only we are going to say, yeah, this particular window is a valid. So we increase our vowel count. And if it is a consonant, then we are adding to our consonant queue to this particular index. We are adding it to our consonant queue. That particular index. Very simple, very straightforward. If it is a vowel, then we will add it to our vowel map of that vowel map of particular characters ka queue pe we are adding. And if it is a consonant queue, then we are adding to that particular consonant ka queue pe we are adding that index. And at the same time, just this is for how many unique vowels we have encountered to check it, to like count it down on the same go. That is going to be vended by vowel count. Now this particular, how we can check this particular window is valid or not. So now let's suppose this len of the consonant queue. What is our driven factor here to invalidity? What is the driven factor for invalidity for our window? So there can be, when you are expanding your right pointer, you are basically ingest a new characters to yourself, right? Every right expansion is going to give you a new character. Your vowel count can be increased, your consonant count also can be increased, but there is no shrinking of your window. So when you are expanding your right, you are basically adding new characters altogether to your answer. So that means either your vowel count or consonant count is altogether going to be increased. But what is actually make your particular window invalid? Just think on the question perspective and tell me. So if you are keep on consuming new characters as a vowel, then do you feel your window is going to be an invalid? I don't think so, right? Because here it is mentioned we have at least one of AEIOU. So if we encountered A, let's consume more A. If we not encountered E, let's try search for E by expanding your right pointer. But if you already expand E, if you already encountered E, then also consume new E, because that is not going to be make anything source, right? Because we can have more. It is mentioned at least one, so we can take multiple occurrence of that particular one. There is no issue. But our consonant, we have need exactly k consonant. So the invalidity of the window information is going via how many consonant we have encountered by this expansion. So when our sliding window has more than k consonant at a particular time, then that means that is a point of invalidity. Let's shrink it. Let's shrink it to your window to make consonant count within the range of k, right? So that's the reasons we have written another for loop. So this for loop basically do these things. So if our len of consonant queue, that is the length of what consonant queue stored, the index of the consonant, if it is length is more than k, hey man, now you are on danger. Let's shrink it. Let's shrink yourself. Now character left, word left, you have taken what is the word left, so you have assigned to character left the same way, the same code I have written. What we have written for right, we exactly written for left. but here we are shrinking. So that means if len of vowel of character, so that means from this vowel map of character left we are just popping out the very first, if it is a vowel. So if it is a vowel, character left is a vowel, the same things we have written. If it is a vowel, then from our vowel map character left we are just popping out its first index. Now as we are shrinking, so which is the first index stored at the vowel map of character, that is the elements we are going to be first popping out when we are shrinking our window. Just, it is very intuitive. Just think, if we are shrinking our window, shrinking from window from the left, and we have a queue ready with all the indexes we have pushed in the order, and we are shrinking our window, and if we are popping out the very left elements, so that means it is going to be on the same order, because we have shrinking from left and we are throwing out who is the very left elements from our vowel map. So that is very intuitive. So that means when we are shrinking, we are correctly popping out the very left indexes. That is the for sure. So now this way we have popping out the very left element, and if it is a consonant, then also same way we have popping out the very left index from it. As simple as that, as simple. No super science, no rocket science we have implemented here. Now again same things. If our vowel count is going to be changed by this shrinking, how we will do? If there is a new vowel is going to be entered, then our vowel count is going to be 1. And now if altogether the length of that particular characters is going to be 0 from the vowel map, then we can say now we have dropped altogether the occurrence of a particular vowel, then we have decreased our vowel count. Like this way we will do this until our window is going to be in a validity range. What is our validity range? Our consonant count should be exactly k. So as it is more than k, it is throwing out. So when it is under the k, it is going to be this while loop is going to be terminated. And after termination, when the while loop is going to be terminated, we will check if our vowel count is 5. So that means we have exactly 5 distinct unique vowel count, and we have len of our consonant q is equals to k. So that is the conditions that is written over the question. So if it is so, then here is a like mathematical trick. So this actually I have struggled some half an hour to figure it out. So there is a like, this is a very good mathematical intuitions we have to put. Otherwise here also we need more time to calculate. So these things to compute everything's under like constant time, so you have to do some mathematical I have to say, like, it is very intuitive mathematical things. You have to like write it down and you will figure out. So what actually is needed, so that means I am just going to be explaining. So just be patient with 5 to 10 minutes more. So that means we have a so we have a index of left till right, which is a valid. So this left to right is a valid window. Now how many, so what is the number of total substring then possible? Total substring possible with is this particular window. So left, considering left and right, we know that this is the for sure a valid, this is the for sure a valid window. Why so? So the reason is because we have already shrink our left when it is more than going to be k, and now we have also put it a check when our vowel count is 5 and consonant q size is also k, then we are only encountering to this particular block, right? Now from this left to right, so we sure there is a one answer is always possible, but how many more? Considering this right, how far your left is going to be valid? How you can shrink your left? So can you shrink your left till here? Can you shrink your left till here? So let's suppose you have multiple occurrences of I. Let's suppose you have multiple occurrences of I till this point. I is a vowel, correct? Let's suppose you have multiple occurrences of vowel till this point. So if you are considering right as a right fixed, right को हम लोग fix कर लिए, right has fixed, right will not move. Now considering this right, how much you can shrink, you can shrink your left so that the answer is also valid. So this altogether is valid, that I know, but this one can also valid. This one after shrinking our left till this point this is also valid. How we can check this? If that is also valid or not? So that validity we can check by a simple math, a very simple math. It is, I don't have to say it's very simple, but yeah, with sliding window and everything and these mathematical things make this question on the more over the medium perspective. It is literally a more than medium question. You can consider it is a hard level question also. It is more than medium, that's the for sure. Now how we can see, now what is our vowel left boundary? Let's go to the note, one note only. So what is the very fast of vowel left boundary? So I can have multiple occurrences, but what is the last occurrences of this I? So can I say that considering I to be our valid range, what is the last occurrences of I? So last occurrences of I is, we can get it from vowel map of I ka minus 1 means what is the last index where I has occurred. So we got this, and for every vowels we have checked what is the last index it has appeared, and we will take minimum of, we will take what we will take if I has occurred here also, let's suppose I has occurred, and let's suppose e is a vowel which is occurred here. Here is a vowel which is occurred here only once, and now to make our entire window to be valid, can we say we can shrink till I? We can't, right? We can't. Otherwise, if we shrink till I, then E has only occurred to that particular index, then E is going to be invalid. Till I we to know because I has occurred this point, but E is going to be invalid, right? Because on that particular window, considering this as a window, there is no E altogether because E has occurred at very last till this point. So we can negate out these I's. That I's we can get rid of, but this E we have to consider. So what is the vowel left boundary? So considering that boundary till my right, answer is very valid. What is this? If let's suppose we have E here and we have A E I A here, A E I O here, U here. So what is our left boundary then? Very left boundary should be our E, not others. So for every vowels we will check what is the last occurrence of that, and within them what is the E's last occurrence? This is this. What is the I'th last occurrence? This is this. What is the O last occurrence? This is this. What is the U's last occurrence? This is this. And what is the then valid vowel boundary? That is for E. Then how we are calculating out of them? What is the minimum? Of them? Every is -1, that is every last occurrence of the index, and out of them what is the minimum? So that means considering that particular point to my right, considering that particular point, this part I am highlighting this multiple times because that is a very tricky maths here. I really need some great amount of struggles to find out this particular formula. So yes, so that's the reason I am keep on repeating. So considering this particular window till last, we have a valid window. So out of all the occurrence of the vowels, out of all the last occurrences of the vowels, what is the minimum? So that is a V. So that is our vowel boundary. So I did exactly same things. I have iterated over A, E, I, O, U, and I have taken every vowels of IT -1. So that means what is the last occurrence? So Python support negative index. So if you write -1, that basically going to be giving you the last index of that particular vowel. So vowel of IT of what is the last index it has occurred. You got it? Now you have minimized it with your vowel length boundaries. I told you, right? Because you have to choose minimum of them all. So you got your vowel left boundary. And similarly for consonant left boundary, what it should be? It is your consonant Q of 0. So that now for consonant we don't have a concept of multiple vowels. So consonant should be any consonant should be valid, and it should occur exactly k times. So we don't have to follow a very complex map of DQ. We are good with following with a single consonant Q. So that's the reasons. For vowel we have choose a default dict of DQ, but for consonant we are using only DQ. So for consonant, what is the left boundary of consonant? That is very simple. If you understood vowel, then consonant left boundary is a very simple. Consonant left boundary is a consonant Q of 0. That is your consonant very left boundary, where first consonant is occurred to your valid window. Exactly, correct. Now, what this text basically signifies? This text basically signifies if your K can also be 0, right? That is one of the edge case. If your K is 0, then your what should be your consonant left boundary? So then your consonant Q of 0, you are going to fetch a particular index. Your consonant Q is altogether empty if your K is going to be a 0, then and you are trying to fetch a particular index, so that is giving you an index out of bound exception. So we have to put a check here. If your K is greater than 0, then only fetch a consonant Q, otherwise make it as a very large value, so that when it is going to be now what is then the possible answer. So you got your vowel left boundary, you got your consonant left boundary. So how far you can shrink your left pointer? How far you can shrink your left pointer? You can shrink your left pointer. So let's suppose on that particular example, you got your vowel left boundary here. Let's suppose you got your consonant, that is your left, that is your left, that is your, यार इस पे जगह कम हो जाता है टाइम टाइम में. So that is your consonant left and that is your vowel left. Now, how far you can shrink your left? How far more you can shrink your left? If so, that is of minimum of both. Your consonant boundary is this, your vowel boundary is this. You can't say I can shrink till here, because then your consonant is altogether going to be rejected. But if you can say you can shrink till here, then your consonant is satisfied and your vowel also satisfied. How? So then out of them, if your, let's suppose your last vowel has, if your vowel boundary is here, like if your vowel boundary is before your consonant boundary, if your vowel boundary here, then also you can say you can't shrink till consonant boundary, then your vowel is altogether going to be on the critical path. So you have to take the minimum of them. So you can shrink minimum of vowel boundary or consonant boundary, and from that particular point till right you have a valid answer. From that particular point till right you have a valid answer. So from this particular point till right, minimum of them till right, you have a valid answer. So then what is the range you have calculated? So your left, let me write it down. So your left can be here, your left, your valid left can be till here, and from till there also you have a, that is your left, original left, and that is the left by boundary, vowel boundary, consonant boundary you have calculated. So till this, it is the minimum window which is going to be satisfied your answer. So can I say, so what is the original left you have taken? So from this boundary left, boundary validated left and original left, so what are the characters till this point? If you add them, so till this you have a valid window. So can I say if I have a letter here, if I include to my answer, that is also a valid, because you know all entire boundaries are valid. If you like insert this particular character also to your answer, then that is also a valid window, and that is also a valid window. So how many different valid windows then you can form? How many different valid windows or different substrings you can form? Considering right as a fixed, and you can shrink your valid left till this and your original left till this. So can I say like my left, what is the left I have chosen? So that is my original left, and out of them minimum of vowel left boundary, consonant left boundary. So that is the origin. So that is the valid left boundary, valid left shrink left boundary. So we have chosen minimum of them, that I just explained to you guys, and I have negated out from my left. So that is something like, we have this boundary. This is our valid left boundary, valid smallest expanded left boundary, and that is our original left boundary. So this gap, how we can find? This minus this minus this. So minimum of consonant vowel is going to be give you this, minus original left is going to be giving you this. So this all together. So let's suppose that is of 3, that is of 4. How many window? 4 minus 3 plus 1. Why plus 1? Because you have from 3 to write 1 and from 4 to write 1. So 4 minus 3 is, considering 4 you have 1, considering 3 you have 1. So how many gap? Plus 1. So that is very intuitive maths. Minimum of left boundary, right boundary minus left. So that is the gap. If you have a gap of 2, so that means you can select altogether 3 elements from here. You just write it. That is very intuitive. So this minus this plus 1. So that many valid window, considering right as a fixed, you can add to your answer. So exactly that I have written here. Minimum of vowel left boundary, consonant left boundary minus left plus 1. So that I have added to my answer. And every time we are running the while loop outside of on the right, so I am just going to iterate, increase my right point. Yeah, that's all about on the today's question. Now quickly discuss on the time complexity. Now, can you guys guess what is the time complexity for this question? The time complexity of this question is big O of 2n. So that is of very trivial. I can just quickly explain you how it is going to be big O of 2n. So your right pointer is going to be for sure visiting all the elements in the words at max one time, because your right pointer is keep on increasing. So your right pointer visiting all your elements at max one time. And similarly, your left pointer also going to be visited. So you might be thinking, hey man, you have also running a nested loop of the left pointer here, but that is not. So that is the beauty of sliding window. That is the beauty of two pointers. You think that is going to be taking off n square complexity, but ideally it is not, because your left pointer is also moving forward. Your left pointer is also moving forward, your right pointer is also moving forward, and your left pointer is also visiting every elements to only one times. You can see our left pointer till this particular window, when we have checked it, we are not going to be again start our left pointer from a particular point, and then we are again keep on increasing our right pointer, which we are doing for the quadratic time complexity, the brute approach. But here we are not doing so. Our left pointer visiting every element. So these elements you can also add some s out also and check it, print logs. So you can see every elements visited by the left pointer at max once, and every elements by the right pointer also going to be visited at max once. So that means every elements is going to be visited twice. So that's the reason that time complexity is twice. And here you can see, here you can also see we are running another for loop on vowel. So that is can be very fixed. That is of 5 vowels only. So you can say that there is of 2n across 5, something like this. So because we are going to iterate every vowel, so the time complexity is something like of we go of 5 2 into 5 into 10 10 10 into n. So 10n, something like how it is. So 10 into n is 2 into 10 to the power 5. So 2 into 10 to the power 2 into 10 to the power 6. So that is our time complexity. And so the final time complexity is something, if I write it on the mathematical term, it is of we go of 2 into 10 to the power 6. And your space complexity SC is going to be how much? Your space complexity, you are using a vowel map. So vowel map can grow every vowels you are storing their index, and you are also using consonant queue. So the summation of sum of, or I can say we go of vowel map space plus we go of consonant map space. Now what they are storing the indexes of what? Indexes of every vowels or every consonant. So that is very trivial. You can say like if your entire string has only vowels, then your consonant map is going to be empty, and if you have only consonant, then your vowel maps is going to be empty. So at very worst case it can grow until of length n, we go of n. So that is our final time complexity, and that is our final space complexity. Yeah, that's all about on today's question, guys. If you till now understand the entire problems, entire concept that I have explained, the variable size sliding window, how we have implemented, how we have calculated that mathematical formulations, and with the one note explanations I did it. If you understood till this point, please do subscribe to our channels. Please turn on the notifications so that you are not going to miss an important note. And yeah, we will be trying to come tomorrow also with another beautiful fresh questions. Cool. So for now, bye guys.